Okay, now we are going to design the heat exchanger network. So for that, go to the design and click on the recommended design and click on solve. So these are the design that recommended by the ASPEN energy analyzer. Uh, it has recommended almost around 10 designs. Okay, so these are the recommended design. You can actually increase the number of the design, the recommended design, just while you are here. Recommended design. So maximum design. From here you can actually change this. You can also add your own design. Just click on this design one. If it is not here, you should click on this scenario one, right click and add design. So this will be added, design one. So we can also add our own design. So this is the grid diagram. If you want to see the pinch, so just click on show hide pinch lines. So this is the pinch is now shown where the temperature of the cool stream is 140 and the hot stream is 150 degrees. Okay, now we are going to place our designs here. So this is add heat exchanger. So you should click this with the right, then hold the right and place a heat exchanger here. Okay, now with the left button, just to drag it here. So the heat exchanger is added. Now click on this heat exchanger and okay, we are actually we are adding this heat exchanger at the pinch point. So at the pinch, this is the pinch point. At the pinch, the cooled must enter at 140 and the hot must leave at 150. So I write 150 here, okay, and I write 140 here. Okay, so these hot is leaving at 150 and the cool is entering at 140. You can see here the target temperature of the cool is 180. So if I click on the tide, so you can see that the cool is now going from 140 to 180, and the heat exchanger that is added has a duty of 8 megawatt, but in this heat exchanger, the hot stream must enter at 203.3 degrees C. So it is not entering at 250, it is actually entering at 203. And you can see now this is a solid line. That means that this portion has achieved its target, while the other lines are still dashed lines. Okay, now we are going to place another heat exchanger. So in the same way, add heat exchanger between these two stream. Oh, sorry. Just click on this, and then you should drag it here. Okay. Again, we are matching these hot and cold stream at the pinch. So double click on it. So that means that the hot will leave at 150 and the cool is entering at 140. Okay. So if I click on tide 230, so that means that if the cool achieve its target temperature 230, it has to take 27 megawatt. How to take 27 megawatt? The hot stream must enter at 258 degrees C. But the hot stream is available at 200 degrees C. So that means that this hot stream is not enough to heat this cold stream to its desired point. So I will just uncheck this tide, and what we have to do, uh, we have to click on this tide. So that means that if this enters at 200 degrees C and will leave at 150 degrees C. So the temperature of the cooled will rise from 140 to 181 degrees C, and 12.5 megawatt is a transfer from this stream. So you can see this is a solid line because it has achieved its target. This portion has achieved its target. However, now these two have not achieved the target, so I can place a heat exchanger between these two. So add a heat exchanger here and here, and now double click on this heat exchanger. So let's suppose tide means that it is entering at 250 and tide leaving at 203. So this is also tide when it is entering at 181 and it is leaving at 205 degrees C and it is taking 7 megawatt of the heat. Okay, now about the pinch, this line has still not, this stream has still not achieved its target. So we can add a heat exchanger here. Uh, so there is no heat available with the hard streams above the pinch. So I will just match this with the HP steam. So double click on this. Okay, this is tied, and you can see this is 7.5 megawatt, which is the heating utility which we did in the uh, very first stage of this process simulation of the heat exchange network. Okay, now we are doing a design below the pinch. So for that, I'm going to place a heat exchanger between these two streams. Okay, this is the heat exchanger. Double click on it. So the heart is entering at 150 here. Okay, while the heart must be, yeah, the heart must be entering at 150, and the cool is leaving at 140 degrees. So if I click on this tide, so that means that this heat exchanger will transfer 17.5 megawatt, and the cool steam input temperature must be 52 degrees C, not 20 degrees C. So it will achieve its target of 140 degrees C. You can see that now this is a solid line there. That means that it has achieved its target. So let me place another heat exchanger between these two lines. And double click on this heat exchanger. And here the heart is entering at 150 at the pinch point, and the cool, we know this now, that it is leaving at 52 degrees C. So click on tight. Okay. And let's suppose if I say that it is leaving at 40 degrees C. So if it leaves at 40 degrees C, it has to transfer 16.5 megawatt. So in order to take the 16.5 megawatt heat, the cool stream temperature must be minus 30 degrees. Inlet temperature must be minus 30 degrees C. However, it is not minus 30 degrees C, it is 20 degrees C. So I will just uncheck this. Sorry, this is, and here, uncheck this as well and check this one, right? So check this one and check this one. So now you can see that 6.5 megawatt heat exchanger is installed here, and you can see that this cold stream has also achieved its targets. That's why it has turned into a solid line. Okay, now we are going to place a heat exchanger here. And this is the utility. So I'm matching this with the cold water and double click, tight. It is entering at 106 and leaving at 140. So 10 megawatt is the cooling utility. So this is the heat exchanger network design for the problem. Thank you very much.